Okay, the last section that we're going to go through in this particular unit about lines is to talk about parallel and perpendicular lines. Now again, some of these things I hope you already understand, that if two different lines are in the same plane, if they're parallel, they do not intersect. So anytime that you have two lines that are both vertical or two lines that are both horizontal, then we say that those are parallel. What happens if they're not vertical, if they're not horizontal? Two non-vertical lines are parallel if and only if they have the same slope. Taking a look at my fancy calculator here, hopefully you can tell that the blue line and the red line are parallel to one another. And we should be able to tell that by virtue of the fact that here we're given the equation of this blue line here in slope-intercept form, y equals 1/2 x plus 2. And here for the red one, it's y equals 1/2 x minus 3. Both of them have a slope of 1/2. The slopes are equal. Those two lines are parallel. So for practice question number 1, which two equations represent parallel lines? Well, in this case, we're going to have to do a little bit of work because the equations are not in slope-intercept form. They're not in point-slope form. We cannot tell what the slope is just by reading the equation yet. So we'll transform them. We'll put them into slope-intercept form. So in this case, I would say we need to add x to both sides. And again, if I want it to look like y equals mx plus b, slope-intercept form, I'm going to put the x in front of the 8. So it's in the right order. Well, okay, I don't have y equals, I have 4y. Divide everything by 4. So this becomes y is equal, remember that's implied to be a 1. So I could split that off and say 1/4 x plus 2. So now I know the slope of that line is 1/4. For part B, again, let's move the x by adding 2 to both sides. So I have 8y equals, put the x in front of the constant. So it becomes 2x minus 16. Divide this by 8, divide this by 8, divide everything by 8. Y is equal to 2/8 reduces down to 1/4 x minus 2. So the slope of this line is 1. Hey, that's the same thing as a. Now what happens here? Again, move the x. In this case, add 4x to both sides. Y is equal to 4x plus 4. Oh, that's already in slope-intercept because we had just one y to start with. And the slope here is positive 4. Wait a minute. This line and this line are parallel to one another because their slopes are equal. This one, not so much. Again, it has to be exactly the same. The slopes have to be equal so we can say the lines are parallel. Let's do it again. In this case, all we have to do is divide by 3, and we'll have the equation in slope-intercept form. Y is equal to negative 5x minus 3. So the slope here is -5. Part B, now again, a little bit of work here. I want to careful. It didn't say 2x. It starts off with 2y. I want to add 10x to both sides to get the y term by itself. So 2y is equal to 10x plus 6. Divide everything by 2. Y is equal to 5x plus 3. So the slope here is, wait, positive 5 is not the same thing as -5. Those two aren't parallel. Well, what happens to the third one here? I'm going to subtract 10x from both sides. Don't know why I wrote that in green. Sorry. -2y is equal to -10x plus 20. Now I have to divide by -2 to all three of these terms. So we get y is equal to negative divided by negative is positive, 10 divided by 2 is 5, positive divided by negative is negative, 20 divided by 2 is 10, so the slope here is 5. Oh, it's these last two, this one and this one are parallel because they both have a slope of 5. The first one, right number, wrong sign. That's not good enough. For number 3, are the lines -x plus y equals 5 and 4y equals -4x plus 16 parallel? Well, again, for the first one, if I simply add x to both sides, I get y equals x plus 5. So the slope there is implied to be a 1. For the second one, I would need to divide everything by 4. So I would get y equals -1x plus 4. So the slope here is -1. No. They do not have the same slope. They are not parallel. So that's a fairly simple relationship there. If two lines are, well, not vertical ones anyway, if they're parallel, they're going to have the same slope. Perpendicular is a little bit trickier. For example, if I look at the graph of y equals 2/3 x plus 1 and y equals 3/2 x minus 2, where here we have a slope of 2 over 3, here we have a slope of 3 over 2, yeah, then no, those are not perpendicular to one another. Looking at these two lines, here I have y equals -2x plus 1 is the orange one, and positive 2x minus 4 is the green one. Here we have a slope of -2, here we have a slope of +2, and again, hopefully you can see between those, that's not a 90-degree angle. Here's an example of what does need to happen. Hopefully, again, take a look at the blue line and the brown line there. This point where they intersect, yes, we finally have 90-degree angles. Here, not 90 degrees. Here, not 90 degrees. What's the difference here? For the brown line, we have a slope of 3 over 4. For the blue one, it's -4 over 3. So we can say two different lines that are in the same plane are perpendicular if they intersect at a 90-degree angle. Well, actually, if they meet at one 90-degree angle, they're really making four 90-degree angles. Any two lines are perpendicular if and only if their slopes are negative reciprocals. They have to have opposite signs, and they have to be flipped upside down. If I can go back to the examples, well, this non-example, here the slopes are reciprocals. They're flipped upside down. One is 2/3, the other one's 3/2, but they're not perpendicular because both of them have the same sign. Here they have opposite signs. One's -2 and one's +2, but they're not reciprocals. This works because they're both opposite signs and flipped. They're negative reciprocals. Suppose you don't have the graph to look at. We can figure this out just by looking at the equation of the line. First one here, let's put it in slope-intercept form by first of all adding x to both sides. And then divide. For the second one, start by subtracting 2x. And then divide by 8. And for the last one, we'll start by adding 4x to both sides. Don't have to do any division at all there. And remember how we frequently have written slope as a fraction. Which pair of lines here have slopes that are negative reciprocals? It's B and C in this case. Here we have the -1/4, and here we have +1/4. Neither of those are perpendicular to the first one because it was positive. Let's do it again. For part A here, equation A, all I do is divide by 3. -15 divided by 3 is -5. So the slope here is -5. And again, I'm going to write it as a fraction as 5/1. Divide, careful. Wait, hold on. We need to move things first. Let's add 2x. Then we'll divide. Y is equal to 2/-10 will be -1/5 x. minus 6 over 10 will reduce down to 3 over 5. But if we're looking for either parallel or perpendicular lines, don't care too much about the y-intercept. It's the slope that we need. Oh, that's not going to work. A and B are both negative. Let's see if equation C is perpendicular to anything. And again, we'd start by subtracting 10x. Careful about dividing by negative 2. Negative divided by negative is positive. 10 divided by 2 is 5. So the slope here is 5 over 1. Oh, again, it's B and C, because here we have negative 1/5. Here we have positive 5 over 1. So again, two lines are parallel if they have the exact same slope. Two lines are perpendicular if their slopes are negative reciprocals. That. So the slope of any parallel line is going to be the same 4/9, negative 4/9, and the slope of any perpendicular, positive 9/4. Let's put the rest, let's see, I guess 7, 8, and 9 all need to be converted. So for number 7, it turns into y equals negative 3/5 x minus 2. So the slope of the parallel is also negative 3/5. The slope of the perpendicular has to be positive 5/3. For number 8, subtracting 8x from both sides, dividing by 12, we get y equals negative 2/3 x plus 5/2. And again, the 5/2, the y-intercept, not too worried about that. It's the slope of parallel lines that are the same. And if anything perpendicular to this will be the negative of negative 2/3 is positive 3/2. For number 9, simplifies into y is equal to 1/3 x minus 20/3. Slope of any line parallel is also 1/3. The slope of anything perpendicular is negative 3 over 1. You could just write that as negative 3. Oh, look, for number 10, that's in point slope form that we looked at a little bit ago. We should be able to, without having to simplify the equation any, we should be able to identify the slope there is negative 3. Any parallel line will also have a slope of negative 3. Anything perpendicular will be positive 1 over 3. So again, here it's in point slope. That slope is 5 over 6. Parallel lines will also have a slope of 5 over 6. Perpendiculars should be negative 6 over 5. And for number 12, they didn't quite finish. I mean, it looks as if like 10 and 11, they started with slope-intercept form in distributed. There's no parentheses, but they didn't finish putting it in slope-intercept form. That's okay. What we're looking for here is the slope. Negative 3/5 for parallel, positive 5/3 for perpendicular. For this next one, I'm going to challenge you to try and do some of the work by putting the video on pause. I'm going to go through and graph each one of those lines for you so you can check. If we're supposed to come up with 8 different lines, goodness only knows what's going to happen to this grid. So I'm going to go ahead and graph number 1. Let me walk you through this just to make sure we're confident you're going to do this accurately. It says to graph a line going through 0, 6. All right, so right there on the y-axis. Oh, look, there's already a dot there. Yeah, let me clean that up a little bit. So again, 0, 6, that's my y-intercept. And with the slope parallel to, now they say y is equal to 1/2 x minus 9. That means the slope of this line is 1/2. They said parallel, I need another line with a slope of 1/2. So that means from this point, I'm going to go up 1 space and go 2 to the right, or down 1 space and 2 to the left. That should be my line. Again, as you can please see those 3 points put together, the slope is positive, it's going uphill. So there's line number 1. Go ahead and graph line number 2. So the point -5, 1 is back here to the left and a little bit up. And they said a slope perpendicular to the last line you drew. Well, the first line that I drew was a slope of +1/2. So for perpendicular, it's going to be -2/1. Not my straightest line ever, but I think it's in the right spot. Now I'm going to go ahead and graph line number 3. Pause the video, see if you can do it, and then compare with mine. So it said parallel to the last line you drew, so I needed a slope of -2 again, which means this one was perpendicular to the first one that I drew. Now on to number 4. Well, this one barely shows up. -8, 9, that's 8 spaces to the left, 9 spaces up. It's almost off the grid. And they said a slope perpendicular to the last line. Well, the last line had a slope of -2/1. This should be +1/2. So the fourth line turns out to be parallel to the first one. Okay, try number 5. We'll start marking these off so I don't get lost. Graph a line going through 0, 6. Well, again, that's where we started with the very first one here. Perpendicular to the last line, so I'm back to a slope of -2/1. Now do number 6. Number 6 says going through the point -8, -8. So that's down here in the bottom left corner. Parallel to the last line. Well, my last line had a slope of -2. That has a slope of -2. It's barely on there. I'm going to try number 7. 2 to go. So it looks like all we're doing here is perpendicular to the last one, parallel to the last one. We're bouncing back and forth between a slope of +1/2 and a slope of -2/1. So we're getting this whole crazy grid here where lines are parallel to one another and lines are perpendicular. All right, one more, 8. So 2, -7, 2 spaces over, 7 spaces down. So we're here in the right bottom part of it here. Parallel to the last line that I drew. Okay, so that's going to be again a slope of +1/2. Up 1 over 2 to the right. Up 1, 2 to the right. down 1, 2 to the left, down 1, 2 to the left. And now it's time for coloring. They want you to color in the areas you can now see above with all of the ones should be green. Did you catch my mistake? It was back here with number 7, I think. I lost track of which slope I should use. I should have gone through the 0.01 and used a slope of positive 2 over 1. I'm sorry, it should have been positive 1 over 2 instead of negative 2 over 1. I need to fix that. There, that looks better. Now try the coloring. There's the green. Here's the blue. And there's the yellow. So again, just to recap, parallel lines should have the same slope. Perpendicular lines have to have a slope that's the negative reciprocal